Is that because let's do the gravity change on that? I'm liking that, though. That's, I think, what we've got to do. I didn't realize it's the position of the camera. That's what we didn't have access to, and I think that's what is involved in the fix in this. So it looks like we fixed the distortion, which I feel good about. Whoops, not dice layer, dice roller. And let's increase this just so we have a bias a little more time to see the direction of those as they're going down. Let's roll it one more time. See them drop. Got my eyes right here. What? Oh, took too long to drop. Got my eyes here. No, it still looked like it was going right towards the center. Do I have to pull back even further? I do like that that these seem to be, doubling and halving right here. Let's do this. Let's say, let's create a var that is a, call it factor, lens factor.
Hey, Mark.
Yeah. Mark had to refresh, missed the fast few minutes, seconds. Did you see my comment? I did. Change the top down, the view to top down, and move the camera back incrementally. We are actually doing that. So yeah, that is the solution to it. So we're changing our view angle, narrowing it, and we're moving the camera back. And there seems to be a correlation between the distance. If I double the distance and halve the angle, I seem to have the dice are showing up in the same size. So I'm going to say lens factor here, if we're saying that's equal to 2, then we're going to say this is equal to 45 divided by lens factor. Whoops, not length, lens factor, like that. And this one, is that right? Yeah, divided by, and this one is going to be 30 times lens factor. And if we do that, that's for 2. Let's make it go to 5 and see what happens. And we are going to refresh. Yeah, the dice seem the same. Let's see how they go. Yeah, they're still all going, here. It's like so I've got a couple options. The other thing I was thinking about doing that I would actually much rather do, because I don't just want to shrink them. I kind of also want to spin them, and I want to kind of bop, as the portal comes up, I want to bump it a little bit. I want the die to just jiggle a little bit to make it look like it's connected, and then I want it to drop down. So the other thing I can do too is I can say, well, let's just have it not collide and then just apply a force to it and have it move. And that might be the way to do it. But the problem is these are all moving down towards that center point, which is still not looking, far enough out. Let's try making the lens factor. Let's go multiply this by 10 and go out to by 50 and try it and see what happens to those lines. See if they get further out apart. Oh, wow, what's going on? Oh, wow, we can't really go that far out. Yeah, so we're not going to be able to solve this the way we want to solve this. I think what we're going to have to do is figure out the line from the camera to the die, and then have the die continue in that direction. That's what we're going to have to do to make this look real. To make it look like they're just dropping down. It's a little tricky, but I think we're going to have to do that. Yeah. Also notice that this distance, the camera away, its ability to detect light is not so good. Look at what's happening with the way the dice are rendered. So we can't really go out that far. We can go out a little bit, which we need to change the distortion. Here, let me demonstrate here. We go at 5, and look at the pieces on the right. They look just the same as the ones on the left. Let's now change that to 0.5, like this, and now we should see more distortion on the outside edges for the dice as they're rendered. Yeah, look at the distortion coming in. See it on the sides? That's what I'm trying to avoid. Okay, so that 5 looks like a good lens factor right there. That's not bad. And now we have to figure out what to do, how to get those dice to move. I think actually my level of understanding at this point is insufficient to be able to figure this out in what I hope will be the span of this show. So I'm going to, I think I have to research this offline and figure out, because what I need to do, I think, is I need to take the Canon object and get rid of it and just instead work with the dice itself as a 3JS object and move it. And hold on a second. You are doing this in init though. Don't you need to animate only on settle and after the portals appear? I am only doing it after they appear. I'm essentially saying die.body.collision response is 0, and when that happens, it falls through the floor. That's what's happening. It might be possible as well to create a hole in the floor. I haven't researched that either, but either way, we're going to get that same problem. I think when it reaches the center of gravity, we get that stack overflow error. So I think what I want to do instead is apply a force to it. And I think I should be able to figure that out, but I think it's going to take some research to do. I need to remove the object from the world. Speaking of which, I do want to see if I can remove it here. Instead of setting the collision response to 0, let's go ahead and do that. We'll refresh here and just watch that. We should be able to see it repeat it again and again and again. There it is. I want to figure out how to get rid of those die that are there. That's what I want to do. Yeah, you think it's a camera animation. I don't think it's a camera animation. Because I don't want I want the other die to stay there. I just want those to go away. But if you're by camera animation, if you're talking about basically saying I got to move it, along the same line between the center of the camera and the center of the object, then yes, I believe that's correct. That's the direction I need to move it in. So that's what I'm going to research. Wow, only 1 under 10 in that group. Those some good rolls. There's a couple ones. Okay, so let's see if we can figure out how to remove the die. Let's see if we can figure out how to do that. I suppose I could do it just by taking its coordinates and taking it off screen. That would be like the easiest way to do it. Die.position. What is it? It's right here. So you just say die.position x. That position x is equal to negative, like that. And that should be enough to get it off screen. Nope. Don't stop debugging. Let's do a refresh here. And then now watch what happens. Oh, that's because our delay is happening too soon. Hold on. Let's do... look for set interval. There it is. Let's change this to every 7 seconds we throw the dice and try again. Didn't work. Maybe that's not how I change its position. Maybe there's a different thing I can do here. Let's... the other thing I could do is I could move it underneath. I bet I could do that. Let's try that. Let's see if we figure out how to do that. So basically 3JS and also Canon. Usually creating a hole in the floor sounds like the right direction. May not be simple though. Yeah, that's kind of what I'm worried about is will there be, how hard is it to do? I have a feeling I'd be writing my own code and then it would be incredibly simple. That we'd have a call that would be punch hole or something like that. And but usually in physics engines, there's a bitmap that specifies what objects can collide with each other. Maybe Canon has that, but still I got to change it because I want the floor to be solid until I basically open the trap door. That's kind of what I'm trying to do is open up that hole. move object. And then I also want to apply force to an object. I want to do two different searches here. There's one. And the other one is apply force to object, like that. And so those are the two things. How to move a physical object. Looks like I've been here already. I'm looking for something a little more Stack Overflow-like. Let's see if we can find something Stack Overflow. Find the quality results here are really high. What is quaternion? Let's see if we can find out what that is. Number system that extends the complex numbers. Huh. Isn't math fun? Okay. It's an alternative to Euler, says Will Bennett. More stable, no gimbal lock. And at this point, I'm like, okay. I now have to look up gimbal lock and Euler, which are, I have a recollection I've encountered that in the past, but that's about kind of where I am on that. So, all right, so I kind of get a sense of the quaternion right there. Let's go look at the code there. Whoops, we were here. Let's just see what happens if we do this. I want to see if I can get these things to move at all in here. So let's not do that positioning anymore. That's not working. It's going to be die.body, die.body.velocity, like that. And we are giving it a 1 in the z direction, which is going to be up or down, I think, in this world. Let's do this ignore comment here, so we're good there. Euler is the pronunciation. Quaternion is for 3D rotation. Okay, that's a nice simple definition. I like that. Thank you. Thanks, Will, for that. All right, so we want to go back out here, do a refresh. See if we can get any movement on the numbers that are less than like this one. Any movement? Nope, nothing. Let's make sure we're yeah, I have a feeling that Canon is maybe stopping that because of the physics engines coming in and saying, no, that's not it. Oh, we got some motion. That time we got some motion. Look at the one. Yep. It's weird. It kind of pops up and then stops is what's happening here. Let's give it 100 is, I think, in the positive direction. Let's change this to a negative and see what happens here with this and see if these, any change here. Huh. They don't really move that much. Oh, could it be because gravity? Because this guy has changed gravity to 1,000 times. Now, let's see it. It's probably going to be really extreme, where they'll probably disappear, go off screen. What are they going to do? Oh, yeah, they're all over. Okay, cool. So we got some motion here. Let's change that to a 0. Let's try this at a negative 100, see what happens. I think are they going to bounce? Yeah, I think they kind of bounced. Let's change it to 10 and see what happens. If they're going to come up, Yeah, I think they came up a little bit. Let's change it to a 50 and see what happens. So positive seems to be coming at the camera. It's Deutsch. I think he was German. It could be wrong. It's not going as far as I'm expecting it to be. Let's go with, like, say, 300 and see what happens in this direction. Okay. Wait, am I doing rotational velocity on this? Angular velocity? Yeah, it's a rotational. I think we got rotational. We're not looking for rotational. Yeah, so while the code is getting us some spin, that's not really what we want. Is it going to be velocity equals new canon? Or wait, well, we've kind of already got it here. What if we just said that? Is that going to work? Let's see what that does. Just playing. Don't be mad if it doesn't work. We're just playing, kids. Here we go. There's a 7. Okay. Nice. Feeling good about that. That's actually kind of cool. It's kind of cool because it's like it's blasted up off screen, which is really cool. I didn't actually think about that. Ooh, I do like that how they come up. Yeah, it's kind of cool for them to come up and then drop down as well. And it would be super cool to give them a little bit of angular velocity as well on this. Hold on. Let me copy these two. Let's undo. There we go. Now what I want to do is I want to do something like this. So that's going to pop it up. Then I want to get a random. And what is it? Is it math.random? Is that what it is? I think that's it. Yeah, math.random times. I'm checking out the Canon docs, not seeing a bit mask. Well, the problem with the bit mask is then now I've got to go to something to get out. I think what we're really looking for, Will, is the ability to cut a hole in something. Right? Does it have that ability? In other words, can I create a cube and stick it right over that dice so that it's penetrating down through the table or the floor, and then say cut one shape from another? Because that might solve the problem without the Stack Overflow, but I have a feeling I'm going to get that Stack Overflow. Anyway, I think that when that goes towards the center, I'm going to get it, which means I need to monitor its height, and when it gets too close to the core of the Earth, I need to stop it. Say, okay, now you're all right. So let's come in here. We're going to create a new number. This is going to be I don't know, call it rand x, and that's going to be equal to random number times, I don't know, like times 20 rand x spin, like this. And let's do let's get a random y spin, like that. And let's get a random z spin as well, like that. And so we'll get all of those, and then we're going to come up here and use them here. So we can get a little spin on this. That's what the bit mask would do. It lets you determine what two objects can collide. So you would clear the bit so the die wouldn't collide with the floor. Okay. I'm imagining a bit map is what I'm imagining. And so, all right, so there's my spin velocity. We've got that, and we are going to do the multiplication there. And so we've got the spin. And there's our setting the velocity, so it's going to jump up and it's going to spin in a random way. Let's see if we get that. Looking at the 2. Didn't jump up very far. I don't understand that. Is the... Okay. Let's change the order of these. Let's try this. I didn't see the spin. So it seems like if I do one or the other, I can't do both. I can't do a rotational as well as a motion. It seems like one cancels out the other. It's not what I would expect. Move and rotate object. Let's see what we get here. Okay. Is the spin large enough is the question. Yeah, I think it is, because when we do here, let's do this. Well, we can do this, say 10 plus this, 10 plus this. We do get a motion if we do it in the other order, but I suppose we could say, let's make this one be like 100, 1000 right there. So we're going to at least do that. Let's refresh it, see what happens. It could be right. That could be a problem. Yeah, they are not spinning. They're going up and landing exactly as they land, as they go up. So, and if I do this, if I change the order and say, let's put the local velocity first, so we shoot them up in the air, right? If we do that and followed by the spin, then they just simply spin on the ground. They just kind of shoot off to the sides, I guess is what they do. Because I think one of the spins is like 100 plus it. Change that to 10 and then come back over here. Yeah, I think it's enough. I would think it would, I would just imagine it would hold it as two different, so even with nothing there and just the random numbers, you just see a little jump here. See, there's a little jump. So I don't get it. I wonder, I guess I could do this, is I could say, okay, I could do this later, spin later. Like I could do something like this. What is it, set timer? Set timeout. And we're going to do, okay, so this is going to be our spin die function we're going to call. And the timeout is going to be, let's say, 200 milliseconds, like that. And then we create our spin die function, like that. And then I think there's a bind. Yeah. And we can bind, I think, the die itself. Whoops, not there. There. Which would make this code go here. So what I'm proposing, you know, this is brute force attempt here, because there's probably a better way to do this. It's simply my lack of understanding of canon, right, that is getting us here. But basically what I want to do is come in here like this, change, let's do this. Let's say var die equals this, like that. And that should get us to that binding. I just want to keep the existing code here, down here in case we copy it and move it back. Okay, so I don't know. Let's see what happens with that. Are they spinning around something that's not? So it works, but what is that? They're spinning around like a center world point, I think, or something. Or maybe they're not even spinning. It's just the force is hitting them at that weird angle. How's the spin defined? Well, great question. I just assumed it was this is with the quaternion, but to be honest, or maybe more accurately, to be ashamed, I have not done any research on the docs on this, on how to do this. How to spin a Canon object. We add 3JS here so we get some better results. How to rotate a Canon JS rigid body. Set from axis angle. All right, let's take a look at that. Maybe this gets us our spin. And if it does, maybe, what was that? That was on the quaternion, okay. And whoa. What's M player must be an object? Yeah, I'm not entirely sure what these values are here. This might be the die. Let's just see what happens with that code right there. And see what that looks like. Wait, did it really? That seemed like it took a long time before anything happened. It's not, nothing's happening. But then when it lands, it does it. That doesn't make sense to me. Yeah, that's in the air. Yeah, that doesn't even make sense. I don't even get what's happening there. Maybe because there's no rotation here yet, and then when we land, maybe this is the problem. I'm not sure what set axis from angle is. Set from axis angle it does. Let's maybe research that. I bet you that's what I have to do. There's no rotation on the Y. What you got? In 2D, the axis of rotation is the z-axis. In 3D, you specify the axis of rotation. Yeah, okay, that's what the first parameter is. So x, y is straight up. Yeah, I don't understand the second parameter. What's the second parameter, though, in this thing? Set axis from angle. Axis of rotation, angle of rotation. Oh, okay. All right. So we've got a video up here, too. I'm going to pop this out here. I'm not going to watch this now.
Hello, world.
Okay, that's awesome. Intro to that, in case anybody wants to see that. There's the quaternions out there. Okay, totally learning something new here today. So the first piece was the, where was it? Where were we? Where were we? We just on something that explained what it was. The first one was the, oh, it's back here. That's where it is. Okay. The axis of rotation.
Mark!
Yeah. Isn't it the prior page to the video? Yeah, that's right. Yeah, no, I got it. No, thank you. Yeah, I'm here. Yes. Then you apply it to your object by, okay, so I did not call this. Oh. Well, I'm just modifying it right out here. I wonder if that makes sense too, to do it. Let's take both of these lines of code. Maybe we can play with something and get us a little closer to this. Let's copy that out, comment that out, come down in here. Now the axis of rotation is pretty sure, going to go buy some chocolate and come thinking of quaternion algebra, then yay. Okay. World Wake, good to have you out here with us, by the way. Thanks for being with us, helping us out here. Okay, so axis of rotation, I'm betting it's a vector. Betting, like that. So we'll just say let that, and can I make it be this type, or is it going to be sad and say, I don't know what you're doing here? I guess if I'm telling it to ignore it, it won't figure that out, right? So there's my axis of rotation, and I'm okay with that right there. So it's going to do some sort of random piece. The axis of rotation, the angle of rotation, this is the part I don't understand, but I suspect it's going to be something like this right here. Oh, wait, they did axis of rotation as that. Yeah, I'm okay with that. I'm still okay with what we're doing. Let's do this. We're going to say the angle of rotation, and that is going to be equal not to that. I'm going to do this instead. And now let's see what happens. And where are we? Here. Refresh. Nope. It's kind of like it's applied it, but it's not actually spinning while it's in the air. It's really kind of odd and weird. It's like it says I've got the spin, but it's not till I land that I'm going to start applying it. Because if I just comment out this line of code right here and we refresh it, it's going to just land straight without spinning when it lands. Well, wait. Those bumped into each other. Let's try this one right here. Oh, they do a little bounce. There's something. Am I setting anything? I don't think I'm setting anything in here. Yeah, I think I could take this out, this line of code out right here and refresh. See what's happening. I think it's just a bounce that's happening, and it's like a small math issue. Yeah, they are. Whoa. What's going on with that? That was a sudden move. It doesn't make sense. So this velocity does work. Getting it to spin at the same time doesn't seem to work unless it collides. Which is probably the engine. So, yeah. Look for angular velocity. I think what you're doing is only specifying rotation for one frame. Angular velocity. Yeah, I am, but I'm expecting it to stick is what I'm expecting it to do. So, all right, let's see what we got with angular velocity. And the other thing too, and it's just occurred to me, we'll do a search for angular velocity canon. Okay, well, that didn't really answer my question how it works. Ooh, tau is angular force. Forces are being set to 0 after each integration step. So if you want to set forces, you'll have to fetch the pre-step events and apply them. Applying angular velocity should give the same result anyway. Okay. Did you try something like this? Let's try it. Die dot body dot angular velocity. Let's try setting that actually here. Just see what happens. I want to get something going here where I'm like, okay, cool. Got movement and spin and we know how to do it. Yeah. Finally. Oh my gosh. Consider when you are updating position. If you change the position, it's only for one frame. For movement, you have to apply a force acceleration, which in turn updates the velocity multiple frames. Gotcha. Yeah, no, I see what you're talking about. That's what we're looking for. Excellent. Okay, cool. Now I have something I can freaking work with. Let's kill the timeout. Kill this over here. All right. Getting, feeling better about this. Right? Getting closer. All right, so we've got angular velocity here. Whoops, I want to use this. I have to write that code again. So let's do this and that. And now kill this using CodeRush's selection increase to grab it and then delete it. There's my spin velocity. Let's just do this. And I think I want to rename each of these. I just want to call this the X spin and the Y spin. And the Z spin. There we go. Now let's try it. Now we should get a random kind of thing here. Let's see what it looks like. Eyes are on the 5. Yeah, I think is it better? Are they all going the different way? Let's make sure they are. Can't quite tell. Is the code right here? I'm getting a new math random for each one of these as I go through it. So yeah, they should all be different. But they kind of are. I'm not getting my eyes on two at the same time. Nope, they're different. They're different. Okay. Are they all flowing the same way though? Are none of them going up and to the right? Yeah, they all seem to be going kind of down and to the left. Nope, that one went up. Okay. All right. Nice. Okay, cool. All right, so let's change the values of this thing a little bit here. Let's... okay, we got that. What's going on here? There's our velocity. We're shooting up. Let's make it just be a little bit. I want to make this way more subtle. And let's refresh it. That's not enough. Let's try 30. That's not bad. It's actually a little bit bad. Let's try 60. they're not coming straight down. It's this angular velocity seems like it's not spinning around its center, is kind of what it seems like. There's this weird kind of motion here that's happening here. I think the other thing that I want to do, I don't understand why they're moving. They should come straight back down because my velocity that I'm giving them is essentially straight up. The y is coming out the camera. So, so I don't get that. So if I drop this down, that could reduce the amount of motion they take. Yeah, it definitely is. It's definitely moving it. It's definitely moving it off to the side a bit. So I need to read up and learn more about angular velocity and moving these objects. The other thing I need to do too is I need to take these items. Essentially, another way of doing this, removing the dice, is to here's with just the smallest spin. Another way of removing the dice is to remove them from the Canon world, but keep the 3JS item and then just manipulate it and move it myself, right? We already know how to essentially move using the physics equation, so we can do that. And then we don't have to worry about collision or being on the floor or anything along those lines. It is coming straight down, isn't it? No, I don't think it is. I think it's, here, let's do this. Let's make this 29 and then refresh. And watch what happens now. Well, actually, oh, you know what I think is happening? Hold on. I think I know what's going on, is that it's hitting before it's leaving the ground because of the, hold on, let's try this. If I set collision response to 0, I bet it comes straight up and down. Let's see if that happens. We still have our bug that happens once it gets down close to the center of the Earth. Yeah, it is going straight up and down. I think what's happening is the spin is it gets a hit just before it takes off, and that's what gives it why it's moving in the direction it's spinning. That's what is happening here, I think. So that I think solved that problem. So we're going up and then out. Yeah, but the fall, now again, though, we have the problem is that we're not falling down the hole, we're falling towards the center of gravity, and because of the perspective of the camera, it's all converging on this point, which is not what I want. It's occurred to me, by the way, that there's potentially a very easy workaround to this problem, which is instead of sucking them down the hole, I just blow them up past the camera. Right? We tried that at first, right? It is kind of a workaround to this problem. In other words, I come in here, let's go back and give it a slower spin, and I say, let's do this, 600, refresh. And it's kind of like that a little bit. Maybe 600 is overkill. Let's do 100. Can you make them disappear as the hole closes? Well, that's what I'm trying. I'm trying to get to that. Yeah. So yeah, I'm trying to get there is what I'm trying to do. So it seems like let's try 200 here. That's kind of cool too. Kind of cool, but I don't want to do it. Is there a way I can apply a force to a cannon body? There must be. Cannon body, apply force. Impulses. Does this engine use homogeneous coordinates? I don't know, is the answer to the question. To fall down, I think you need to scale. You have only one camera, so changing, yeah, we'll keep saying scale it, Mark, scale it. And I guess we could do that, but it's just not going to look like it's actually dropping because I'm not going to get the scaling right. What's going on with impulses? Demonstrates how to add impulses and forces to a body. Cool. Body apply impulse. World point. Add an impulse to the center of the world. Where's gravity on this world? That's interesting to me. Let's see what we can do on this. So I'm going to say collision response is no. I'm going to say die.body.mass is equal to 0, which means gravity won't affect it. Let's just try that and see where we get with that. They shouldn't move now. Oh, they just rotate. Cool. Are we good? We are not good. We have a stack problem as well. Have we been having that forever? Let's comment this out. Let's do a refresh. Maximum call stack size range error in vmult and quaternion. Okay. Let's try, just see if we're in the same spot or is this a different spot? Same spot. That's what it looks like to me. Okay. Let's try this. I just want to make sure body mass 0 is not a problem at all. And I'm looking right down here at the bottom here. Yeah, it's totally hidden by the chat window. I think I have a clean version of it with no chat right there. Yeah, so interesting. Same place apparently, vector to local frame. I didn't look far enough down. But we have a problem. It doesn't like it when we set the mass to 0. And yeah, it doesn't like that either. So we got a problem here. But I think kind of what I want to do is I want to get this thing to move. I want to say no for you, no on mass. Then I want to move it and I want to intercept before we get to this problem here. This is the thing that makes me so nervous though. It just is a sign I'm not doing this the right way. And then there's the exception right there. Let's go down here. What are we doing in here? Maximum call. So we're in world step, internal step, get contacts, box convex, 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 find separating axis, test separating axis, project, vector to local frame, vmult. Cannot start another throw. Yeah. So mass of 0 creates an inverse mass of 0. Physics engines usually consider those objects as not movable. Well, that's kind of what I want to do. I can't think of how it works without having a camera per die. Yeah, but I can't. Maybe I don't understand something on this right here. I need these to move from the perspective of the one camera that we're projecting onto. So I don't see how multiple cameras help me at all on this. With regards to getting this to work. We can, I guess we try shrinking. Fine, I'm going to try shrinking. I really wanted to move it down underneath, is what I wanted to do. I wanted to get it to fall, but that is just not going to work today. I think we can try working. As a theoretical curiosity, in the real world, each object rotates around its own axis. And Surly Dev is also, I think we talked about this, I mentioned this before. Surly Dev asked, can you make them disappear as the hole closes? And so I can do that too, but I want them to get smaller first. And so let's look at making them get smaller. Ugh. Not happy about it, but let's try that. Let's also find out how to make it, how to scale an item. Canon. God, I feel like I'm so close here. There's just something I'm missing here. I think an impulse force, being able to, and shoot it in the right direction and at the right force, everything will work. Oh yeah, of course, getting smaller to give the appearance of falling through the hole. I hate it though, because I tried that in my mock-up and it just doesn't look real. Because the rate at which you get smaller changes depending on gravitational force, the camera angle, how far you are away from the object, all of those things. And the 3D world already calculates and figures that whole thing out. And I'm not, and since we're going to simulate it, I just think it's not going to look that good. However, with that said, let's try and do that. Let's see if we can fake it. So let's go and see if we can find Canon scale. This is really maybe a 3D, a 3JS thing. 3JS scale world object, scale object, maybe. All right, I don't know. Let's try. So this sounds like it's being able to scale in each direction. Let's just throw in, let's comment this out, and just throw in, what is it? Die dot body or die dot mesh? I'm not sure if mesh is on. What's mesh on? Perspective cameras, what does that mark? That's why I'm thinking you need multiple cameras or use homogeneous coordinates to scale. I'm not familiar with Canon, so I do not know how it operates. I am just speaking in general. I gotcha. Okay, here's my mesh here. Mesh, scene, add mesh. Uh-oh. Wait. That's not the right mesh, I think. Wall material, left. Where's the die? Update body from mesh. Die.mesh. Oh, that's the line of code I wrote. I'm not sure if that's going to work. Yeah, I don't know. All right, we'll just try it and see what error, if we get an error. Check the console window. All right, cannot read property scale on undefined. Yeah, so maybe try die.body.mesh, see if it's there. Surely dev is out. This drone. What do we got? Yep, doesn't like it there either. Yeah, certainly dev's trying to get all the coins. All right. I need better example code is what I need. See what we got here. So everybody says do this, but they expect me to know where the mesh goes. Where is the mesh? New 3 mesh. Do I have to reapply the mesh? Yeah, I'm finding a real absence of sufficient sample code. scale.set. What if there's a scale on body? Is it too much to hope for that? Let's give it a try. It's almost faster to try it than it is to search it. See what we got here. Nope, it doesn't exist there. All right. Well, that was helpful. Die.body.scale. Well, what the heck, we'll throw this out here too. And I'm sure that's going to be unlikely, but I'm not getting too much else. Whoa, kids. Don't give up. Don't give up. Kind of awesome, but it also shows we're going to have to.
Just wow.
Yeah, we're going to have to recover the, big die. Yeah, the little one hasn't rolled under a 10 yet. All the others have rolled under a 10. That little guy is still rolling over a 10. That's the die I want right there. Look at the collisions not working. The collision detection is not working on these, right? Canon thinks they are small still. Oh, the little one just got big. Okay, so we can scale. Finally, all right. So we need to animate a scale is what we need to do. So let's do that. It's a little sad. Make the die proportionally representative of the value. Yeah, I like that. Fine. We're going to do that just for this once. Just to see how crazy things are. It's going to get crazy here, even with this. Uh-oh, not what I wanted to do. Scale factor, let's do it at 0.1, like that. 100, does that make sense or no? Because then they'll go down.
Great suggestion.
Let's do it by 0.2, like that. What's my suggestion? Oh yeah, that one right there. Let's try it. Here it goes. Based on the number, but there's only impact ones less than 10. So we'll see what happens. Yeah, it's kind of cool. All right, let's do it for all of them. Put it outside, no matter what. Kind of fun. Here we go. Nothing happened. I get an error. What's wrong? Oh, my die. That's going to be better. All right, try one more time. Yeah, kind of fun. It's not in body. Yeah, kind of cool. All right, so we're going to animate the scale. We are going to animate the scale. And I'm so not happy about it, but we're going to do it. All right, because that, at least we can do it, and it gets us closer to solving this problem and essentially saying that we did it, I guess. I think, but like I said, I'm going to have to do some research on this. I think there's a better way to do it. So let's... Yeah, I'm with you. I'm totally with you, Will. Sad panda. Here's what's going to make me feel a little bit better. Let's add Will's name right here using the new latex formula feature of CodeRushed with Omega IL. By the way, Will, if you ever become a rapper, I think that should be your name, Omega IL or Omega Ill. I think it would be an awesome, awesome name. Yeah, okay, so let's see. We're going to go to Yeah, we tried a lot of dead ends here. And I really hate that the hack is our way out of this thing. So we need to add the die to an array is what we need to do. So let's do this. Let's say the scaling, yeah, actually I don't want to do this here. Let's do this down below on its own line. Var scaling dice is equal to that right there. There's my array. In here, the minute we need to start scaling, dice stop rolling, we need to kind of reset that, clear it out. Okay, like that. Then down here, we need to say scaling dice dot push the die. So that's going to push that in there. Then I think we need to set well, we need to scale it. We need to do something to scale it. And I think it's going to be somewhere in here, scale dice if necessary. Scale falling dice. How about that? Scale falling dice, like that. Come in here, let's create the new function, scale falling dice, and now we want to check to see if our the dice that we're scaling is has anything in it. So something like this: if scaling dice and scaling dice dot length is greater than 0, then we're going to do something in here. And let's see. What are you laughing about, Will? Was something happen that I missed? Sun? Oh, you switched to the sun. I bet that's what happened. I want a latex comment for my nickname. What's your nickname, Surly Dev? Hold on. Is it just you just want it for Surly Dev? I think we can do that. Hold on a second. I need to get. Let's actually do that because I want to do a little bit of fun for a second because I've been hitting my head over this. Let's come in here and say latex Greek symbols, and take a look at these. All right, so I'm going to drag this off the screen. Isn't this fun? This is the size of the last rolls that they were before they changed. All right, so let's create we're going to create a comment here for Surly Dev. So our S is going to be a regular S. Our U could be mu. We could use that. That might be fun to do. Do I have another one, Greek letter that's closer? I do have upsilon, so we could do that. So we'll do the S, and then dot U gets me the upsilon right there. There's that one. And then R, yeah, rho doesn't really look that good, so we'll just use a regular R. And then L, could do iota, looks a little bit like an L. Dot I, like that. Are we liking this yet? Little e is epsilon here. Let's do that. Dot E. And then the Y is, the uppercase Y is kind of cool here, actually. Dot uppercase Y. Oh, I thought I had that. Dot lowercase y. Wait. Oh, it's dot uppercase U, because that's the epsilon. It's not the Y. Surly. We liking this yet or no, Surly Dev? Is it looking a little too weird? Maybe that Y there, that epsilon at the end, is not looking as good. We'll just put a regular Y there. Surly, and then Dev, D, and then dot E for epsilon. And what do we got for V? VVV is new. Interesting. Dot N is looking a little bit like that. What do we think? Is that L not so good? The iota? I think it's a little bit better. Maybe the U too. I don't think I like the epsilon very much there. All right. There you go, Surly Dev. Your wish is my command. There you go. Done. That's you. By the way, you can create a CodeRushed template that just spits that out if you want to, if you got CodeRushed installed. Okay, scaling dice and scaling length. So if that's the case, then we want to go through our scaling dice. Sierra Uniform, Lima, Yankee, Delta, Echo, Victor. We forgot the Romeo in there, I think. But yes. Yep, forgot the Romeo. Okay, here we go. Scaling dice.length. And inside of here, we want to get each die. And in here, we want to do something based on the time that we started, and set it, whatever the value is going to be. Let's just do this right like this. Then the other thing we want to do is before we start, let's do this. Let's just, for now, we're not going to do any animation. For now, we're just going to cut them in half, is what we're going to do. And we'll do that as long as we have those in here. Then what I want to do is I want to, before we start a new roll, I want to clear out all of these, get the scaling back to 1 for all of these. So we scale to 1, to 1, to 1, like that. And so now, if we do it and refresh, we should see everything cut in half its size. And we won't have any animation, but that should be it. And then when they come back and roll in again, they should be back to their regular size. Okay. I think it's maybe going to... Oh, shoot. That didn't work. Why did that work? Scale, die.scale set. I'm super confused. Do I have to do it down over? I don't even get it. Is it an ordering thing? It doesn't make sense to me. Did I not refresh? No, I did refresh because we saw one of those changes. Why aren't these dice coming back to the regular scale? Okay, clearly not working. Let's make sure this code is being executed. Code is not being executed. Oh no, there it is right there. It is being executed. Why does set scale work once and not the other time? Die.scale set. Am I doing that wrong? Am I doing dot? Yeah, no, I'm doing it the same. It's the same call.
Cut.
Yeah, I don't think it's, I think it's 1. Here, let me prove it. I don't think the problem is that I'm giving it the wrong one. Let me just change it to 1 right here, and you should see no change, I'm expecting. Yeah. Setting it to 1, I'm like really not getting why this scaling is working here, and yet the same code, the same line of code up above is not working. Does not make sense. Surly Dev, ooh, just saw my comment. Oh, okay, you weren't here for a little bit. All right, gotcha. Well, that's certainly a surprise. I don't understand that. Why does scaling work when it's moving and doesn't work when it's not? What if we do it here? Oh, we can't do it there. I need to iterate through all of them. I think it's a sequencing issue. Let's create a new function here called restore die scale, like that. And let's see if we can call restore die scale at another time. Like, well, it's got to be somewhere inside random dice throw is the problem. Try it at the beginning, and then we can try it at the end. I don't think, I just don't think, I don't think the beginning's going to have any difference on it. Let's see what we got. Let's change the scale because we need to be able to do that. Change it back to a 0.5. Refresh. Yep, not working. Not working before. Let's call it after at the end. I think that's the end of it. Yeah. Is the scale on the body? I'm not seeing it on their docs. It's not on the body. It's on the actual object itself. So, and that's what I'm doing. So I'm calling it on the object. So we're seeing it scale, but it works in one place but not the other. I just put it at the end. Let's see what happens now. If this works. If this doesn't work, I'm like, what, really? Okay, let's see. Do they come out regular size? Nope. That does not work. They're super cute, though. That 16 is the only one left that hasn't rolled less than... No, wait. Some of them it's working on. What's going on here? Hold on. I got an idea. I think I know what might be happening. I think scale falling dice, scaling dice, this needs to be reset at the right time, and I think it's not being reset. So I think we are going to be able to actually get this to work here in a second. Let's see here. Here's the random dice throw. Scaling dice is equal to that. If we do this here, and then we come back to restore dice scale, and we move it back up right after this, I think that might fix it. So my theory is that the other code is going back and shrinking again right after we rescale them before we continue to move. I think this might fix it. Let's see what happens. That fixed it. Wow. Okay. So cool. All right. So now all we have to do is animation. We have to animate that scale so it looks real. And then we got to cover them up. So we're getting closer to actually being able to say we did it. All right. So let's figure out the animation. So we want to go to about, I think, let's play with the final look of this. What I think the final look of this should be maybe about 3.3. Let's see what a third of the size looks like, and about the time. I want to see when do we want to make them disappear. That I think is a good place to make them disappear. Okay, so we're going to scale from 1 to 0.3. That's where we're going. So we're basically the total distance we're going here. Total distance, total scale distance is equal to 0.7. That's what we're going to do. And then based on the time and how long we need to go. So let's figure out how long we need to go. So the portal becomes open right about here. Right here's where it becomes open and we should start to fall. Maybe there. So that's at frame 22. And it closes, starts to close like here, 50. So 22 minus 50, I got 28 frames at 50 milliseconds per frame. So let's go in here and we'll kind of do this total frames is equal to 28. FPS. Roy's going to be so jealous all this code without him. Yeah, FPS, we're at FPS 20, which is equal to 50 milliseconds per frame. So that's in milliseconds right there. And then, so we're going to say the total time to scale is equal to FPS 20 times total frames. Like that. And let's see here. Then we have to figure out how much time has passed. Well, we need to grab the time up here when we've stopped. So when this dice have stopped rolling, I'm going to come in here and say the dice settle time is equal to performance.now. Okay, that's our dice settle time. Let's come up here and declare that like that. Then we're going to come down in here and we're going to say, okay, how much time has passed? So we're going to say elapsed time is equal to PFN minus the dice settle time. And let's put this in, what's our total time to scale is in milliseconds. So we're in milliseconds there. So our percent of travel distance, percent traveled. I don't want to be surly, Mark, but there's no E. Oh. My bad. Right there. I forgot, need to initialize that or default in the subtraction Wait. Oh, right here, dice settle time. Hold on. Yeah, you're right. Because right here, we could kind of get around that a little bit. Oh, you see, if not that, or scaling length is equal to 0, then we can just say return to get out of here. That gets us, that makes it way less likely to get here without setting up the dice settle time. But we can also come in here and just, you know, that's not going to hurt. No one's going to notice that. Okay, so percent traveled, like this, that number is going to be equal to elapsed time divided by total time to scale. Right? Then we're going to say, so we're getting closer. These are starting to light up here as we're using them. Then we want to say distance to travel, or distance traveled, we can just say that. That's equal to percent traveled, shoot, I had it, that's what I wanted, percent traveled times total scale distance. Then our new scale, I know there's by the way, I realize I could probably do this in 1 or 2 lines of code, but when I'm figuring this stuff out, it's so much clearer to me if I do this, and ultimately when I get done with it, the code runs about the same, so there's not really a performance benefit, and I love that my brain is smoking. Will Bennett, by the way, I haven't said this, I think, yet today. Thank you so much for that, for the assistance there. I love it, by the way, when we do this. This is, for anybody who's not recognizing this effect, that effect is from our particle system, which we built in earlier episodes. And I love it whenever I look up, and I've been thinking really hard, and it actually, you can see that I'm thinking hard. Okay, so this scale is equal to 1 minus distance traveled, I think, if I've figured all of that out correctly, which means we don't need this down here. We just need this, this, and this. And let's maybe rename this to new scale, like that. And I'm feeling like that is pretty good. Surely, Dev, we're better with that now, right? Thanks for pointing out no E. And I think we're in better shape there. Surely, Dev, right there. So kind of cool. Yeah, the dot U, we kind of changed this, but we could go back here. The dot U there, get the epsilon right there. It looks a little like a V to me, so I'm not exactly sure we want to do that. So we only get the epsilon, and the nu at the end is really what we're kind of getting there. But you can do it. It's not bad. Okay, so is that it? Are we ready to test? I think we're ready to test, is what I think we're ready to do. Let's see if that math worked out and if we've got any problem. I just want this to work, by the way, kids. What do you think? Certainly, Dev said, that's awesome. Cheers, Mark. I think he's talking about the image there. Coder's formula comment. It looks like you took a picture of it, of the screenshot. Oh, nice. Nice. Right there. Yeah. Okay, cool. All right, so we've got some, it's not bad. I can kind of buy it. It's weird that they're coming back up too. What's going on with that? Let's figure that out. Why is that? Is my distance traveled becoming negative? Somewhere in here I need a check to just basically get out of here. I think basically is if elapsed time is greater, okay, fine, I agree, then the total time to scale, I think this is where our bug is right here. Then we want to return. And I think that's the fix there. Let's see if that fixes the regrowing. That fixes the regrowing. Cool. All right. Next. All right, cool. Let's do the final bit on this, which is we want to cover it up. So to cover it up, let's figure out what we're going to do with this. Let's take the portal here, this effect. I'm sorry, this sequence. It's called die portal mockup. Wait, did I modify this one instead of the other one, the wrong one? I totally had the wrong one up. All right, fine. Let's rename this one. Get the names right on these. So this is going to be the mockup. And I'm just going to put the number 1 out here so we don't confuse it with the other one. And let's get this one, that one right there, rename that. This is becoming the animation. Okay. And then let's come down here, rename that, get rid of the 1. Okay. Now we're going to get the animation. That's the one we want right there. We don't want this one. And we're going to take this one, the animation, we're going to duplicate it. And we're going to call this, yeah, this is why I thought I was working with it. So we're going to call this the die portal top layer animation is what we're going to call it. And let's open that up. And close this one so we don't accidentally modify the wrong one. So the top layer, whoops, looks like I deleted it. Okay. So the top layer, it's going to have no background at all behind it. Let's go into this. And this is the glowing cubes tunnel. I'm going to remove that. Good. That's step 1. Top layer also really doesn't need to do anything until we close. And it doesn't need the outer stuff either. It really only needs the inner stuff. So I'm going to cut this right here. I'm going to remove all this to the left of this. Yeah, we'll bet it. He eventually gets it right, Surly Dev. Eventually. The fun is watching the journey and playing with the results, certainly. So now the other thing I want to do is I want to get rid of this stuff on the outside of this. So I'm going to just drag a crop over into this. And we're going to come down in here and we're going to say, let's crop the whole thing out, add a mask, and I want to invert the mask. So we just have the insides of this portal. Because what I'm going to do on the top layer is I'm going to essentially have this animation go on, play on top of the dice, and then I'm going to make it, then I'm going to get rid of it somehow, which we still haven't figured out how to do, but we're going to have to, we'll figure that out hopefully. So there is that. So this is my top layer of animation, just like that. I am going to feather this a little bit. Feather the edge of this like that. Let's see what that looks like. Yes. So that just is going to blend in and I'm not going to see a sharp edge as it closes. Okay. Now I'm going to generate this as well. And I'll go ahead and put it out here. I'm going to call it the die portal top. Like that. And we'll generate it. We'll save. Export. Will's Amazon Prime movie is on pause. Well, we've got to solve this in the next 48 hours if you're renting it, right? Okay, so we've just generated that. Do I have the folder still up? It looks like I can get close to it here. There's the dice roll fireball. Here's the dice portal. I put both of them in here. Might have been a mistake, but here they are. Whole bunch of empty ones at the beginning, followed by here's where the thing starts. I did that because then we can just start them both at the same time. How big are these resources? 14K each. So it's not too bad. 2K down here. So it's not too bad to load up all those frames. So let's go ahead and do that. And that's going to be in the dice layer. So we're going to come in here, duplicate this, go to the dice portal top is what these are called. I should have the exact same number of frames, 73, I do. Same frame rate, same origin X and Y, but I'm going to add it to the front layer of the effects. Front layer effects, add. Then, when we add a portal, test portal, hold on. We need to change this to be dice portal top. Like that. And then when we add a portal, we need to add it in both places. Like that. Like that, X, Y, and 0. And I think that's it. Let's see if that works. Whoa, that like totally worked. And we got rid of them. We didn't see there, it kept them in right there. We've got to actually get rid of them. But the last time we got rid of them because of a, all right, here we go. Yeah, I got rid of them because the timing came up. By the time it was just lucky that it started the roll again. Okay. All right. So next we got to figure out how to make them disappear. Yeah, it's a linear. So see, by the way, we'll see how it looks like it's linearly moving away from us because it's scaling at a constant rate. I need to accelerate that scaling. Modify it a little bit at the beginning and then a lot later. And I just can't think of the math right now to do that. So I need to do that. Also, as that goes down, I need to spin it. Yeah, I really need to somehow have it not move. Those lines of code that I commented out, these two, if these two would work, watch this. It'll work once, but watch it. Because now we'll get a spin as they go down. It looks way more interesting, I think. I think it will. Yeah, look at them drop down. Yeah, and then we die. You can change that with a tween. Yeah, I need to, spinning as they fall would be cool. So yeah, so there's the spinning as they fall, but I only do once because I get that cannon stack overflow. Because it just doesn't like me taking an object that is mass and then removing it essentially from the world. Let's do this. How do I remove an object from cannon but keep it in 3JS? Somebody asked that. Well, I got remove object from scene. Well, this is 3JS though. Scene remove. I bet it's world.remove. I bet there's a world.remove and a world.add. Let's see how these are added in here. I'm not seeing anything that says world.add up here where I would expect it to be. Is there a world.add? Ooh, floor body, right wall. These, I added all of these. Add contact material. I think we're not going to find it here. World add character. Yeah, okay. So then we're over there in this. I think that this is all happening inside of dice.js. Is that right? Yeah. Let's do a search here. I think the dice are added through here. So this is kind of how it gets added using the dice manager. So then we would say dice manager.world.remove. Maybe the die's body. I guess we could try it. Let's try it. But now it won't spin though if we do this. What if we did this? We took it out right here. We said, hey, if new scale is less than 0.33 or 34, like that, 35, like that. If the new scale is less than that, then we just remove it from the world. And so we would say dicemanager.world.remove, and it would be die.body. And then I think we still only get one run of this, because I think the next time we're gonna have to add it back in. But if that works, Mark's getting too proficient. Surly Dev is getting too proficient collecting coins. Time to change the rules. Like make the drone heavier when loaded up with coins, or more likely to explode if you float it right around here. Or you lose coins. If you're hanging out in this part of the screen, you lose a coin like every few seconds. It just goes away. Something like that. All right. Blow up your drone right before collecting. Sure. Or just when your drone blows up, you lose coins too. I don't know. We'll play with some ideas. We got some ideas here. All right. So I want to do this, that. See if removing the body is going to work. We got maybe one shot if it works for us. I think it's going to work once, and then we're going to have a trouble. And is it gone? I think we had a problem. It feels like it's a... we had this problem first. So maybe the remove worked. Let's... what if we did this? What if we said die dot? Because it's really all just about a timing kind of thing here. I'm not sure what these original values were, but I assume that those are there. And then maybe we didn't do this. I don't know. I know I'm kind of playing around and not really sure if this is going to work or not. And did we get I think we still got an error. Yeah, we still got it. Okay, well, I think I'm going to have to do a little more reading on it, figure out how that is all going to work. That's what I think I'm going to have to do. And I think I'll end the show now with that. I am not going to give away a copy of CodeRushed like I normally do. However, if you want a copy of CodeRushed and you don't have one, I want you to just say it in the chat right now. Even if you're out there lurking and you want one, let me know. I will contact you on Twitch DM. Anybody who's out here right now live in the show that wants a copy that doesn't have one, and I'll get you a free license to CodeRushed just for hanging out. Surly Dev, I was hoping you would save me from having to install ReSharper. I think I've just saved you, Surly Dev. Yeah, I'll contact you right after the show. Anybody else, you got like a few moments to do that. Okay, so we've got to tweening. I've got to research tweening, something I've never done. I have a sense of what it is, but need to look at that. And I have a sense of what the formula is going to look like, but that's it. To get that scaling right, I need to research how to remove an object in a way that's not going to result in a stack overflow for the engine. In general, everything I've seen about Canon so far I really like, but I think my intuition is going against the way parts of it are designed, and so I'm running into these problems where I've got stack overflows, and so I'm like, okay, let's back up, let's research more, let's figure it out. So I got to do that to figure out how to get the dice to actually be properly removed when I want to remove them. We're going to need to add sound effects. The sound effects are going to be coming soon, but I think we're definitely getting closer. I think with a little bit of research, a little bit of tweaking on this, I think we're going to get an effect that's believable and doesn't cause problems with the engine. And Will says you've got a current license, not sure when it expires. Yeah, Will, you've got yours is I think a year-long license, and I think you got yours a couple months ago. But Will, if today was the day it expired, I would just give you another one because you're so helpful all the time, right? So if you continue to be helpful, you by all means you can get that. All right, so excellent. Thanks everybody for joining me. Will, you can watch your Amazon Prime movie. You can start hitting play on that again. And just thanks so much, and we'll see you maybe tomorrow, maybe Monday, and maybe Tuesday. We'll see. One of those two. Tuesday at the latest.